We're going to be continuing on in our journey with trigonometry, and we're going to take a look at the trigonometric functions, quadrantal angles, that's angles that are located in quadrants in the coordinate plane, the reciprocal identities, the signs and ranges of function values, Pythagorean identities, and quotient identities. This is a very big chunk of information, so you're going to want to pause this video as we move through it, take some notes, but also be able to walk away so that you can absorb everything in smaller increments. With trig functions, we can use the x and y values in the coordinate plane to describe a triangle. Trig gets its name from triangle, so most of what we're doing with these functions is going to involve a triangle. If I look at this triangle here, I have an x value, a y value, and then I have what I call r, which is also my hypotenuse. So using the Pythagorean theorem, I can find the value of r by squaring x, squaring y, adding them together, and then taking the square root. I can also define all of my trig functions in terms of that triangle. So if I'm looking at this triangle and I want to find sine is going to be my y value over my r value. Now many of you might be familiar with the term SOHCAHTOA. If I have SOHCAHTOA, sine is the opposite over the hypotenuse. So all you have to do is draw the same triangle. I'm always located at the origin. The opposite leg is y. The hypotenuse is r, which is why sine is y over r. Cosine in SOHCAHTOA is the adjacent leg over the hypotenuse. If I'm located at the origin, the leg that's adjacent is x, the hypotenuse is r, so I have x over r. And then tangent is opposite over adjacent. So here, if I'm at the origin, opposite over adjacent. Then we have our cosecant, secant, and cotangent. And if you look at these compared to what they're next to, you should notice they're just the flip. So they're the reciprocal identities of sine, cosine, and tangent. So really all you need is the word SOHCAHTOA and a triangle, and you'll be able to keep this information straight. We can find the values if we're actually given values within the triangle. So if I'm given x is 8, y is 15, and r is 17, I can then find all of the trig functions using that information. I'm always at the origin. If I'm at the origin, I've got this point 8, 15, and that's what tells me 8 and 15 are here. I find r from taking the square root of x squared plus y squared. Sine would be my opposite over my hypotenuse, so it would be equal to 15 over 17. Cosine would be my adjacent over my hypotenuse, 8 over 17. Tangent would be opposite over adjacent, 15 over 8. So let's look at an example. If we want to work this out from scratch, if I have the point 8, 15, I'm going to draw my triangle. My radius is going to go to 8, 15, which tells me my x and my y value. To find my r value, I'm going to use the Pythagorean theorem just like we did, and then there are my answers I just gave. What I like to do is I like to find sine, cosine, and tangent, then I just flip them over to find these three. So I don't personally use the triangle for cosecant, secant, and cotangent. I just flip them over and I stick with finding the first three trig functions. If I wanted to go through the point -3, -4, I'm going to show my coordinate plane. I'm going to go through to the point. I'm going to label my x and my y, and I'm going to find r by the Pythagorean theorem. Then I'm going to use my SOHCAHTOA. Opposite over hypotenuse would be -4 over 5, and we can put that negative in the front. The lab isn't too picky about this. Then we have adjacent, touching, hypotenuse, cosine is -3 over 5. Then I have tangent, which is going to be opposite over adjacent, which is going to give me a positive 4/3. And then I'm going to flip all of them. Notice when you flip them for the reciprocal, it doesn't affect the sign. This is another example that you can work through with this one, where I'm using x and y. When I use x and y, we can use any point except the origin to work with this. Because I have a radius here of a hypotenuse, I can select any value that I want to use for x as long as I have a corresponding y value, because it's going to be along this line. So I can choose randomly x equals 2. You could choose x equals 1. I wouldn't recommend choosing 100 or a large number. I'd recommend keeping it kind of small. Then you're going to plug into the equation to find your y value. Once you find that, your triangle is set up and you can find r, and then you can find your sine, cosine, and tangent. It's okay if your r value has a root in it. If you can't simplify things like the square root of 5, that's perfectly okay. We can leave that as -1 over the square root of 5. But the lab will not take this as a final answer because it has to be rationalized. So if you remember from our algebra classes, we multiply by square root of 5 over square root of 5 so that we get a nice rational answer. So all of this is coming from this right here. If I draw my triangle, my opposite over my hypotenuse, my adjacent over my hypotenuse, my opposite over my adjacent. And then I'm going to take and flip. Now notice when you flip, I'm not flipping the rationalized answers, I'm flipping right here. So this would be negative square root of 5, square root of 5 over 2, -2. So that's where these are happening. You don't want to flip the rationalized ones because then they're not going to be in the right format. Here's another example of what happens when we're on an axis. So when we are on an axis, we have a unique situation where we really can't draw a triangle because it's on the axis. It's very, very odd. So what we do is we just use those values, and my radius this time becomes 1. So I have my sine of 90 would be my y over my radius, which is going to be 1. For your radius is always 1 if it's on the axis. So you're still using the x and the y coordinates. So here my x coordinate is 0. My radius is 1 because it's on the axis, and I get 0. But if I have something like down here, 1 divided by 0, that's considered undefined. Here, this should be, is a typo. This should be 1 over 0, which is undefined. So you got to be careful when they're on the axis and make sure you're keeping in mind that your r is always going to be 1 in that case. Here's another example. It's on the axis, so my r value is going to be 3 because I'm at 3, 0, not 1, 0. This is called the unit circle, and when I have the unit circle and they're at 1, it's always going to be 1 for the radius. This is a little bit of a different type of question. We don't typically show these right away, but if you're located at something other than 1, so if you were here at -1, 0, my radius would be 1. Because I enlarged this, my radius is technically 3. So your radius is how far it is from the origin. And then you're just following through with your y over r. Keep in mind, your radius is always going to be positive. It can never be a negative number. When I have an undefined function, that's going to be when the terminal side is on the y-axis or on the x-axis. When it's on the y-axis, tangent and secant are undefined. When it's on the x-axis, cotangent and cosecant are undefined. You're going to figure that out as you work the problem, but if you want to copy that down to have in the back of your mind, that's perfectly okay. Here's a table you can utilize when you're dealing with the unit circle on the axis. So this would be the point 1, 0. This would be the point. This would be 90. This would be 0, 1. So these are just the ones that you're gonna find this from doing the triangle, but the textbook does put it into a chart for you. Do you need to memorize this chart? No. You'll be able to figure this out using those triangles. When we're using a calculator, you need to make sure that your calculator is set to what we call degree mode. Now, I utilize the Web 2.0 calculator. That's what I prefer to use. And you'll see some videos of using that, and I will be able to show you with the Web 2.0 video how to put this in degrees. So we're going to come back to this in the Web 2.0 video I'm going to show you. One of the most common mistakes with trig is setting your calculator to the wrong answer. So every single question you work in the lab, you're going to want to read and see if they want the answer in radians or if they want the answer in degrees. They're pretty much going to tell you what they want it in, and then you're going to have to adjust your calculator accordingly. Now we have what we call the reciprocal identities. We've already talked about this, that cosecant is the flip of sine. So when I show the flip of sine, I can call it 1 over sine. I can call this 1 over cosine. All that is explaining, hey, when you flip sine, you get cosecant. These identities are going to be helpful later on as we move through things. Now, here is my caveat. If you know that secant is the flip of cosine, you don't have to use this reciprocal identity. They'll come in handy later in the course, but you should just know you have to flip 5/3 to get 3/5. You don't have to use this method. You'll be able to just use the flip. The same thing happens here. If I'm wanting cosecant and I want sine, I can just flip it over. If I flip it over, I'm going to get 2 over the square root of 12. Look at that right here. And then I'm going to go through and rationalize and simplify the denominator. So you don't have to worry about that. This is a very helpful table. I prefer this image to this table. What I would do is in the quadrants, I would put positive, positive, positive. So that's what greater than 0 means. Here, x is negative, y is positive, the radius is always positive. Here, I have x values that are negative, y values that are negative, and an r that is positive. And so in this image, I find that it's a lot easier for us to understand which trig functions are positive, and if they're not positive, they have to be negative. So if I want to determine the sine of 87 degrees, so I'm just asking you, is this going to be positive or negative? I'm going to go here. This is 0, this is 90, 180, 270, back to 360. 87 degrees will be in quadrant 1. That means that all of my trig functions are positive. In B, if I want to look at 300 degrees, that would lie in quadrant 4 because this is 0 to 90, 90 to 180, 180 to 270, 270 to 360, which puts it down here, which means that cosine and secant are positive, so sine, tangent, cosecant, and cotangent are going to be negative. So all you have to do is find a location, and that's why I really prefer this over the chart. When we have negative 200, let's remember how that works from our previous lesson. Negative 200 means we're going to go this way. So this would be 0, this would be 90, this would be 90, and 180, 180 to 270. So if I'm reversing everybody, that puts me in quadrant 2 because it's between 180 and 270. So sine and cosecant are positive, and all of my other trig functions are negative. I could also tell you that sine is greater than 0 and tangent is less than 0. Well, what does that mean? That means that my sine value is positive, my tangent value is negative. So they're asking you to find the quadrant where that happens. So let's go back to our image. Sine is positive in quadrant 1 and quadrant 2. So I want to know where is sine positive, but I also want to know where tangent is negative. Well, it can't be quadrant 1 because all trig values are positive in quadrant 1. So it would have to be quadrant 2 because sine is positive here and tangent is going to be negative. In part B, I'm looking for where is cosine negative and secant is also negative. So I'm going to go back to here. Cosine is going to be negative here in quadrant 2 because whatever is not listed is negative. Cosine's also going to be negative here in 3. So I have 2 or 3. Then I want to know where secant is also going to be negative. Well, secant is the flip of cosine. So secant would be negative here as well as here. So I get 2 quadrants for the answers because there are 2 possible places where they could be negative. The range of a trig function, why is this important? If you get a value larger than 1 or smaller than -1 for sine or cosine, your answer is wrong. The angle can be greater than that, but the actual value that you get, that ratio, that fraction, can exceed this range. Tangent and cotangent could be any number. There's no restrictions. Secant and cosecant are any number except 0. We're never going to get 0 out of those. So if I just want to know, is it possible to get 2.5 out of sine, I can refer back to my chart and say 2.5 is somewhere before -1, so no, that's not possible. Tangent can take on any value, so this is positive. possible. Secant has to be greater than 1, so this is impossible. So look at that secant range. It's going to have to be 1 or greater, -1 or smaller, so 0.6 isn't going to happen. Now, I can find all the trig functions given any trig function itself. So if I have sine theta is 2 over 3, I know my y value is 2, my r value is 3, so I can solve for x. When I solve for x, I'm going to use the Pythagorean theorem, x squared plus y squared equals r squared, but this time I'm solving for x. So I'm going to square the 2 and the 3 and subtract the 4 from both sides, which gives me x squared is 5. So x is plus or minus 5. How do I know if it's going to be positive or -5? Well, it tells me it's in quadrant 2. If I go back to my image in quadrant 2, what are my x values? In quadrant 2, my x values are negative. So that means that it's going to be the negative square root of 5. That's where that came from. Then I'm just going to use my information, x over r, negative square root of 5 over 3, r over x, 3 over negative square root of 5. The lab will not take this as a final answer, so you've got to rationalize that denominator. And then I can simply flip my other functions to find cotangent and cosecant. Next, I have some Pythagorean identities. I call them Pythagorean identities because I'm squaring values. So sine squared plus cosine squared is 1, tangent squared plus 1 is secant squared, and 1 plus cotangent squared is cosecant squared. You need to copy these down onto a sheet of paper to keep as a formula sheet along with these, because they're going to be useful throughout the entire course, and we're not really going to use them a lot right now, but we are going to use them later on. If I want to find tangent and sine, given that I know cosine, you could plug into Pythagorean identity. I would not. I would solve this the way that we just did. So my x is square root of 3, my r is 4, I would plug into Pythagorean theorem. That's how I would do this. You could definitely do it this way, but I would use the triangles and do it the other way. If I'm given a sine value and a cosine value, you could still use the triangles to find tangent, because remember, tangent is y over x. Y over x. You don't have to use this identity. Be careful when you choose the correct sign with the square roots. You're always going to want to go back and look at what quadrant it's in, and that's kind of how you're going to reference back to decide if it's positive or if it's negative. I could actually backtrack and find sine and cosine, given that I know tangent is 4 over 3, because tangent is going to be y over x. So I know my y value is 4, my x value is 3, and I could do the Pythagorean theorem to find my r. I would not follow the method in this example. So I wouldn't do this. I would just find r to be 5, and then I would look at what quadrant it's in. So you don't need to follow these steps. These are unnecessary, complicated steps. Find r by the Pythagorean theorem, and you're going to wind up at the same place as long as you're checking your quadrants. And that's the end of this section. Be sure to watch the Web 2.0 video for a little bit of explanation on how to change the mode.